In this video, we are going to discuss about thread synchronization, and we're going to implement thread synchronization in Java. So what I'm going to do is I will first give you an intuitive example, a popular example of producer and consumer example. So let me write here producer consumer example, and first I'm going to explain you what this producer consumer example is, and then we are going to implement this example in Java. First we will implement this producer consumer example without using synchronization, and then we are going to observe the output in that case. Then we are going to run the same example using synchronization, and then again we are going to observe the output. Then we will be able to understand why actually we need synchronization between threads. So let's now start with this example, the producer consumer example, which is a popular example. So let's try to understand this. So let's suppose we have a producer here. So I'm going to say that this is a producer, and what a producer does, he creates or produces let's say n number of items. So I'm going to create a variable n. So let me just let's just initialize this value n as 0 initially. So after the producer will produce an item, he will increment the value of n by 1. So n becomes n plus 1, and there is a consumer which consumes this product. So I'm going to write here that this is the consumer. So since a consumer is going to consume this product, he is going to decrement the value of n by 1. So now we have a producer and a consumer, and let's say n is the number of items. Let's say n is the number of items like this. So the producer will increment the value of n by 1, and what we are going to do is we are going to for the sake of simplicity, we are going to produce and consume 5 items in this tutorial. So we are going to consume and produce 5 items. Alright, so let's suppose there is a programmer who wants to implement a production line, and what the programmer wants is that the producer should first produce these 5 items, and at each step the value of n is incremented to 1. So what will happen is the producer at the first step, he will increment the value of n by 1, then he will increment the value of n by 2, and then 3, and then 4, and then finally 5. So after the producer, or we can say after the production line has completed the production of all the 5 items, now the consumer will start consuming these items. So now what consumer is going to do is this is the flow of producer. Now the consumer is going to decrement the values of n by -1. So now consumer will start consuming this product from here. So now this is the ideal situation where we want a producer and a consumer to produce and consume these products. But the case is that producer should first produce all these 5 items, and then only the consumer can consume these items. Now in a multi-threaded programming, what we are going to say is that this producer, let's suppose this is a thread. This is a thread, and this consumer is also a thread, and you can see that both of these threads are actually manipulating the values of n. So this means that thread producer is changing the values of n, and consumer is also changing the value of n, and such type of variables are known as shared variables. Or you can say that this is a shared resource, because this resource is being shared by both the producer and the consumer. Both are sharing, or both are changing the values of this item. Now what we'll have to do is we say that we will in a multitasking environment, we want the thread producer to first do all the production, and then the consumer thread will start doing the consumption of all these. But what happens when we create a program, when we create a thread or these two threads? Now you can see that these two threads are dependent on each other because they have a shared resource. Now what happens when I will initialize both of these threads at the same time? So let's suppose these two threads, or the producer and the consumer, they both started production and consumption at the same time. So what will happen is, let's say that the thread producer starts the production first. So the thread producer will increment the value of n by 1 at the first step. At the second step, the producer will increase the value of n by 2. But what happens is that since this is a multitasking environment, the thread consumer can also simultaneously do the consumption of this resource, which is n. So what happens is, when we create both of these threads, and since they are running simultaneously, at this point the consumer thread will start decrementing the value of n by 1. So n will get equal to 1, and then again let's say the consumer will decrement it by 1, and let's say now the producer has started producing this item by incrementing the values, and this will go on so and so. So what the programmer initially wanted is that the production line or the thread producer completes production or complete its execution, and only after this thread producer will finish executing, then only this thread consumer will start the consumption or the execution. But we have seen that this is the problem, that if we are running in a multitasking environment, both of these threads will start simultaneously. So let's say this producer starts first, it may happen that the thread consumer starts in between, and what will happen is it will start corrupting the values of n or changing the values of n, which is not desired by the programmer, which is not desired output. So what are we going to do here is we are going to introduce synchronization. Now if you want a thread to access a shared resource and change its value, and while it is doing that you want all the other threads in your program to not access this resource, you have to introduce synchronization. So let's see what we actually want to achieve. We want the thread producer to access the shared resource n equals to 0, and let's suppose the producer is calling a function. Let's say the function name is update items. I'm going to write here update items. So let's suppose the producer is accessing this update items, which actually changes the value of n as n equals to n plus 1 if the producer is calling this function. So what we want to do is we want to stop the consumer to access this function while the producer is executing. So if the thread producer, if one thread, so I'm going to say a very important line here, that if one thread is accessing a shared resource, then I want that all the other threads in the program, if they are trying to access this resource, I will have to stop them. So this is the task that we need to do. So how we can do that is, whenever a thread starts accessing any particular resource, it will create a lock. So it will create a lock. So I'm going to draw here just a representation of a lock, and this is actually known as mutually exclusive lock. Mutually exclusive lock. So what is the function of this mutually exclusive lock is that if any thread is trying to access a resource or a function, and it will develop a mutually exclusive lock, which means that this shared resource is exclusively available only for this particular thread. So if any other thread tries to enter into this shared resource or try to access this shared resource, this lock will not allow it to do. So now let's see how Java can actually implement this lock. Well, this lock, mutually exclusive lock, in short it is also known as a mutex lock. A mutex lock, which is really an important concept, and it is also asked in a lot of coding interviews. So now what we want to do is, let's see how Java implements this mutually exclusive lock, and how as a programmer, as a Java programmer, I can implement this mutually exclusive lock. So let's take a look. So what Java introduces is, Java introduces a keyword known as synchronized. And this keyword, when we will introduce this keyword to a function in front of a function, so what I'm going to do, I'm going to write this reserved keyword in front of this function update items, and what it will do, it will create a mutually exclusive lock. So if the thread that is trying to access this shared resource will be only the thread in the whole program to access this resource, and all the remaining threads will not access that. Alright, so now we're going to see, now I'm going to write a program which is a producer consumer program, and we're not going to use synchronization first, and we will observe the output, and then we are going to use this synchronized keyword, and we will see how the production is actually working first and then the consumption will start, or vice versa. First the consumption is starting, and then after the consumption has ended, the production has started. So let's try to implement that in Eclipse. So now you can see here, this is the main function, this one, and this is our main class. So now we are going to first create a class update items, and we will create a function update items, and we know that this function is going to be the shared resource in our example. So we're going to create a class producer and a class consumer, and on the basis of this we are going to implement the producer and consumer. So now you can see these both classes implements the runnable interface. So we are going to create a thread of a producer class and a consumer class, and both the threads will try to reference or call this function update items, and we are not going to use synchronization at first, and then we will check what will happen if we will use synchronized in front of this function. Alright, so let's begin. So what I'm going to do here is, I'm going to create an object of the update items, and after creating the object of update items, I'm going to pass that object to the to both of these classes, which is the consumer and the producer class. And what I will again do is, you can see here I have created a constructor, and basically this is a parameterized constructor which takes the reference to the update items, and in this constructor we will create a thread that will implement the thread that will further call this function update items. So let's start with this. So let's first create object of the items, and I'm going to say that this will be the update items is equals to new update items. So now I have created an object of the update item class. So let's now call the constructor of the producer class, which will further create a thread which will be the producer thread, and here we will have to pass the reference of the update items because it was a parameterized constructor. And the same thing is what we're going to do with the consumer, because both of these are actually trying to do the same implementation. So now you can see this is the consumer, it has the same code, and you can see the run function inside this, which we are going to override. And you can see there is a for loop which will run 5 times. So I'm going to write 6 here so that it will run 5 times. And similarly in the producer also it will run for 5 times. And since this will run 5 times, we will have 5 cases or 5 productions of items and consumption of items. So let's start with the producer. So I'm going to create a thread reference which I will call as the P thread because it's the producer thread. And what I'm going to do is I'm going to create a reference to the update items, and I will call it as P temporary because we will need this reference to call this function which is the update items. We need a reference to this, and since we are going to you can see in the producer we are going to in the constructor of this producer, what we're going to do is we're going to assign this temporary reference equals to P items, which means that in the main class you can see I've created an instance, an object of the update items class. So you can see that the same object is being passed to both of these classes, but since the constructor will have 2 different references, as you can see here, it will have 2 different references. So we are going to initialize this reference to the reference of ptemp because we are going to use this reference to call the function which is the dot update items function, which is this one. And in the update items I'm going to pass a value because this will be able to recognize which thread has called that function, because on the basis of that we are going to increment the value of n or the number of items and or decrement the value if the consumer thread is calling that function. Alright, so far we have done this. Now here we will have to create the thread. So what I'm going to do is I'm going to initialize the thread now like this, pass the reference which is this, and let's say the name of this thread is producer. Alright, so now I'm going to start this thread. So let's start this thread using the dot start function like this. So now this function start function will just run this function which is the run function, and it will run for 5 times, and every time we are going to call this update items. And again I'm telling that we are using the ptemp because it is the reference of update items class. Same thing is what we are going to do here. We are going to create a thread like this, and again we are going to create a reference of the update items class, and this time I will call it as ctemp like this. And these are 2 references, and 2 references are calling the same function, so and that too in the main function. So there is an instance of this class update items in the consumer class and also in a producer class. So when we will use synchronization, the synchronize function will be able to know that the different references are being used to call this function update items, so it will be able to create a mutual exclusive lock for it. Alright, so in here in the consumer constructor, what I'm going to do is I'm going to first create a reference, an object like this, which is initializing the thread, and this time we are going to say that this is the name of the thread, like this. Alright, so after this we are going to assign the reference ctemp as c items, and this should be underscore. So c items is actually the reference which was passed by the main function, and we have assigned it to ctemp, and we are doing this because we now want to use this reference to call the function. So c temp dot update items, and we're going to pass 2 this time as an integer. So if the value is 2, that means we have called the consumer thread is calling this function which is the update items. So I'm going to write here that if chk, which is check, is equals to 1, it means that producer is calling it. So we are going to increment the value of number of items by 1, and before that we will create an integer which is the number of items. Let's say it's n, and I will assign it as 0 because initially there are no items. And if the producer calls this, so the variable which you can see, this one is the shared resource, it will be called. So if the producer is calling the this function, so the check will be equal to 1 and we are going to increment, else we are going to decrement the value by 1 because the consumer is calling it. And after incrementing, what we will do is we will display the number of items and also the value. So if we are incrementing the value by 1, this means we are actually producing. So I'm going to write here producing like this, and I will print n here. And similarly I'm going to do this with the consumer case. So I'm going to write here consuming. So now what will happen is you can see that these two are the actual these two are actually calling the producer and the consumer thread with a reference to the items, and both of these classes have their own reference to these items. So when different references will try to access the same function, the main function will be able to know that too, and synchronized, if I will write synchronized in front of this function, then it will work, because that's how JVM will be able to know that two references are trying to access the shared resource. Alright, so this is the program, and let's try to run this program and see what is the output. So let me just first remove some errors if there are any. So there are no errors yet. Let's try to see the output. Alright, so it's saying producing 1. Okay, so we have done a mistake here. Alright, so this is happening because I have not called the dot start function. I will have to call this function thread dot start function, then only it is going to start the consumer. So let's run this again and see what happens. Alright, it says producing 1 and this. So actually it is not incrementing the value by 1. Alright, so I think that since the thread is calling this function update items again and again, it will always initialize int n equals to 0. So you will have to place this line above here so that it does not update the value of n as 0 every time this function is being called. So let's run this program again. So it says producing 1, producing 2, then consuming 2, consuming 1, and you can see here that at the time it was trying to produce the items, the consuming thread just popped out and it started decrementing the value by 1. So you can see this is the unexpected output, undesired output, because the program is not synchronized. So you can see here that after consuming, again the producing thread pops out and it starts producing by incrementing the value by 1. But that is something which the programmer does not want, and since this is not a synchronized method, which is the update items, it is not synchronized, and that's why it does not prevent the consuming thread to just start the execution. So now what we are going to do is we are just going to write synchronized here, and using this keyword synchronized in this function will be able to create a mutually exclusive lock, and this will just enable a particular thread. If it is producing thread, it will execute first, and then some other thread which is consuming in our case is going to execute. So let's run this program again. So now you can see here it first produces all the items and then it will reduce, or it will try to consume those items. You can see that this use of synchronized keyword has enabled us to lock a particular thread. Thanks for watching.